So today's topic of our simulation is the impact analysis on a truss-based structure, that is a pyramid in our case, and I will show you the step-by-step procedure how to perform the simulation. So we have selected 3D model which we have imported from another CAD software, and we have selected our physics as a solid mechanics physics and study as a time dependent study. So this is our contact pair which we have to make. You can see this is basically this area of contact and the second area of this rigid wall. As we have to study, this rigid wall will fall freely on this pyramid and will deform its structure. So this is a contact pair which we have created. The contact pair is important in impact analysis. In order to carry out simulations, we have to define which parts we are going to pair, or the parts which will go to collide each other. So this is our geometry, in which we have imported this geometry and created it as a form assembly. And for the material, we have selected the material which we have selected for our pyramid, and this is our fixed base plate having density of this Young modulus and Poisson's ratio, which is from the material usually. For the rigid tube, that is at the base, 4 rigid tubes are at the base, and this is their material properties. You can see it's an elastoplastic material, rigid base, and this is our moving wall which will produce an impact on this pyramid of this Young modulus of this Poisson's ratio and density. Now coming towards our physics, we are using solid mechanics physics, in which we also have to identify the contact pair. This is our contact, like we have discussed it earlier, and both of the pyramid and the rigid wall are both in contact. This is the contact method which we have chosen is penalty dynamic. There are a number of methods which we can choose, but for an our case study, we are using penalty dynamic. And this is our contact pair, you can see. Now moving, also it is important to make the material of this pyramid as a plasticity material. We have to produce, since we have to gain the results on this pyramid, and in impact analysis we are giving this material a plasticity module using John Cook hardening model, this one. And the initial value, since the wall will move in the x direction, this is our z-axis, and the wall will move in the z direction along with the z-axis in the negative direction. So we have chosen 7, we are given the value of 7 meter per second as the structural velocity field. For fifth constraint, base is to be set as a fixed constraint. In order to receive the reaction force, we have to give fixed constraints. This is our mesh which we have created. You can see it using finer mesh over here. You can see it clearly. Now for the study which we have chosen, time dependent study, you will see the results. So yes, for the results we have here, these are the results. This is the deformation which have occurred. You can see the base plate that is also deformed. Here you can see the pyramid is also deformed, and this is the base of the pyramid. You can see it's the wavy structure showing the compression of the load. So this is our deformation. We have three outcomes from this study. Number one is this deformation. Number two is the stress contours. You can see the surface. You can see here these are the surface contours and stresses that are being occurred after the collision, and these are our deformation contours. These lines represents deformation contours. Also the stress distribution throughout the pyramid. So yes, then we have also created the graph of the stress versus strain that is directly proportional, you can see. And for the force versus displacement, this is our force versus displacement graph. We have obtained from this study. So yes, thank you.